Hello everyone, welcome back to another kinetic tutoring episode. Today we're taking a look at some AP chemistry work. So I've decided to add in some chemistry content into my YouTube videos. So we'll see how it goes. I'm just gonna start from the beginning, go to the end of all the units in AP chemistry. So we're starting with unit 1.1, moles and molar mass. So let's get straight into it. So here's the first question we're taking a look at. It says, calculate the number of moles of CH410 present in 2 grams of CH410 or C4H10. All right, so the first thing we want to do is to find the molar mass of C4H10. Here I've put a periodic table. So on this periodic table, we have the molar mass under the name of the element. Here it says 12.009, but most periodic tables use 12.01. So the mass of carbon is 12.01, and we have 4 of these. So we'll multiply it by 4, which gets us 48.04. And then we have 10 atoms of hydrogen in the empirical formula, or not the empirical formula, the formula given to us. And hydrogen, the mass of hydrogen is 1.01, and when you multiply that by 10, you get 10.10. Now you add these together to get 58.14, which gives you the molar mass of 1 mole of C4H10. And now we only have 2 grams. So in order to find how many moles we have, we divide the amount in grams that we have by the amount of grams in 1 mole. And the answer that we're going to get, this I'm going to calculate, and 2 divided by 58.14 gets you, we're going to round to 2 decimal places, 0.03 moles C4H10. So there you go. That's how you would go about solving the first problem. Let's go to our second problem, where we have to find the number of atoms of silicon presented in 35 molecules of silicon. So the atomic mass of silicon is 28.084. Let's write that out. 28.084, and the amount of silicon we have is 35, so we divide the actual mass by the molar mass, and this gives us 35 divided by 28.084. Round to 3 decimals, you get 1.246. 0.246. This is how many moles you're going to have. And using Avogadro's number, we know that this times 6.022 times 10 to the 23rd is going to be how many atoms are in 1 mole. So when we multiply these together, that's how many atoms are going to be present. So let's give it a shot. 6.022 times 1.246 gets us, if we round to 3 decimals, we get 7.503. What I did is I multiplied this by this. We got 7.503. Make sure to include the 10 to the 23rd. That doesn't go anywhere. And yeah, that's how many atoms are going to be present. And now let's go to the final question. Oh, sorry. I missed the first question, and so I guess we're going to go in a different order. But it doesn't matter too much. They're not really related to each other, or it doesn't matter what you go in, rather. Okay, calculate the mass in grams of of 8.2 times 10 to the 22nd molecules of CHCl3. So we can see here this is 10 to the 22, but we want it to be 10 to the 23 in order for it to match somewhere around Avogadro's number, because we want to find out how 8.2 compares to the 6.022 in Avogadro's number. So when we multiply by 10 to get 10 to the 23rd, we have to divide the other term by 10. So this is equal to 0.82 times 10 to the 23rd. All we did was multiply this side by 10 and divide this side by 10 to cancel it out. So we know that Avogadro's number is 6.022. That's how many, here's how many atoms are in 1 mole. And this is how many atoms we are presented in our sample. So we're going to divide. These two terms cancel out. So 0.82 divided by 6.022, we get 0.136. 0.136 moles of CHCl3. Now let's see what the molar mass is. Multiply this by the molar mass and we'll be done. The mass of carbon is going to be 12.01. We'll add the mass of hydrogen, 1.01, and then add the mass of chlorine, 35.45 times 3. 35.45 times 3 is 106.35. So when we add these up, we're going to get 119.37, and then we multiply by how many moles we have, because this is one whole mole, but we only have 136 over 1,000th of a mole. So we're going to do that calculation. That leaves us with 16.234. And that is the mass in grams of 8.2 times 10 to the 22nd molecules of CHCl3. So there you go. That's how you would go about solving these three problems, converting between moles, grams, and atoms. If you have any further questions, leave them in the comments below. And if you enjoyed this video or if it was helpful, make sure to like and subscribe. It means a lot. And yeah, I'll catch you guys next time.